So welcome everyone to the Dalton Expert Insight series. I'm Shao Kai, one of the Dalton champions. I will chair this seminar. And the name of this seminar is Nuclear and Net Zero, the global state of nuclear. It will be a panel discussion. The nuclear role in net zero has been emphasized more often. We see the power plant construction projects being announced, and especially stimulated by the surge electricity needs. For example, AI, energy security, and carbon credits. Such driving force also facilitates the investment into fusion, not just fission. So while the global vision of nuclear is very clear, the regional reality may differ greatly. So how are we progressing? Can global collaboration unlock shared success? We're going to talk these queries and welcome today's panel, Joan Matthews, Alice Cunha da Silva, joining online, and also Princey Mutuberney. Should we give a round of applause to welcome them? I will give a very brief introduction to our panel. So Joan is a nuclear technology expert and visiting professor in Dalton Institute. And Alice is an innovation lead in Westinghouse Electric Company, driving digital transformation in nuclear sector. And Princey is an energy activist and the founder of Africa for Nuclear Energy, advocating energy equity and innovation. As our discussion is under the global landscape, they will share their insights from their regions and fields. So Joan will cover the region of UK, Asia, and Russia. And Alice will cover Spain and Brazil. Princey is covering South Africa. So the overview of today's topic will include the current status in the world landscape. And we will talk about policy and regulation. We will talk about uncertainties and enablers. We'll talk about the relationship of nuclear and net zero. We'll also talk about fission and fusion. And at last, we will have the speaker to call to action. So we'll begin with the first part. We'll talk about the current nuclear landscape. We will start with Joan's talk, and he will give a very brief introduction to the global status. And then we will have Alice and Princey add on based on Joan's talk. Shall we welcome Joan?
Yes. Okay. Right. So can I have the first slide, please? Oh, I've got is probably the most important, and regulation, uranium supply, spent fuel management, development of the right skills and capabilities, the introduction of new, more advanced but smaller systems, and then where the finance is coming from, and the integration with the renewable energy. Next slide, please. So lots of who does what. Who finances the construction? Who manages the project in situ? Who constructs the reactor? Who operates the reactor? Who supplies the fuel? Who manages the French fuel? Who is the regulator? Now, one of the challenges I would give you with respect to this is venture capital reactors with not much basis. How are they going to engage with that list? Next slide. A good indicator of what countries have developed some skills is the ownership of research reactors. We've seen a number of countries closing their research reactors, and unfortunately in Britain we've only got one at the moment, and it's a military one. But we see here the list of countries, and if we go to the next slide, we can compare that to power reactors that are operating around the world, including those that have been either permanently or temporarily shut down, or and in some cases reactors that have been built but never commissioned. And you can see that there's a growing list of countries that are starting now with new reactors, countries like Turkey. Next slide, please. Oh, project, sorry. Yeah. Yeah, so the power projects that are going on at the moment, we see that Egypt, Turkey, and Bangladesh are new countries which have started programs. And in all cases, they're all being built by other countries. If we go to the final slide. These are the countries that can supply reactors internationally at the moment. You see that South Korea is very active, so is Russia. Russia and China are both trying at the moment to construct reactors everywhere in the world. The United States has capability. The Japanese, despite the effects of the Fukushima accident, are also trying to work on projects, but at the moment they're having to work with other countries. China has not yet constructed a reactor overseas and is still constructing foreign reactors on its territory, but they're planning now to promote their own designs. France has a history of doing this, but at the moment, apart from building the EPR in the UK, France is not building anything. The UK had most of the skills removed in the 1990s due to the contraction of the manufacturing industry in the UK. But it's reopening with small modular reactors with the Rolls-Royce reactor. So those are just the main points that I'd like to use as fixed points to perhaps help the discussion in this session.
Shall we have Alice to add on to Juan's talk?
Sure. I have slides, but I cannot seem to share. I don't know if you can allow me to share.
Can you try it again?
Okay, perfect. So hello, everyone. First of all, just I want to thank you for the invitation. It's a pleasure to be here. The reason I'm going to talk about Brazil and Spain is because I'm a Brazilian, and I started my nuclear journey in Brazil, but I currently live in Spain, so I can bring a little bit of the perspective in these two countries. As it was mentioned, I work for Westinghouse. I'm also VP of the International Youth Nuclear Congress, if you don't know IUNC, and part of the Women in Nuclear Spain board. So I just want to bring a little bit of perspectives on Brazil and Spain regarding their nuclear projects, and the field and the challenges, as was mentioned. So just to start, in Brazil, this picture here is from the power plant in Brazil. In the very back, you see two buildings, which is the Angra 1 and Angra 2, the reactor buildings. With one is a Westinghouse design, the other one is a German design. And this construction site here is for what is supposed to be Angra 3, that is currently stopped, the construction. But as you can see, the site is beautiful, and I'm not, my unbiased opinion is the most beautiful power plant in the world. So to tell a little bit about how is the energy mix, these, and I apologize for the Portuguese in the slide because this graph was one that I found most accurate. So Brazil energy mix is most renewable. We have more than 80% of renewables. That includes hydro, which is the biggest part of our energy mix. And then we have solar, biomass, we have wind, and it's even growing. Nuclear right now accounts for around 2% of the energy mix, because we have only 2 power plants operational, producing power. And as was mentioned in Professor Juan slides, Brazil has 4 research reactors currently operational as well. So one of the cleanest matrix in the world, Brazil has it in the sense of having more than 80% of renewables in the mix and 2% of nuclear. However, we also have a big industry in oil and gas. We do have coal mines in the south of the country, and we do need to decarbonize other industries, not only the electricity sector. So reaching net zero is a challenge to the country, even though we have a very clean matrix. So right now, we have 2 power plants in operation. One is Angra 1. Angra 1 just went through life extension. So in 2024, it was supposed to be the end of this 40-year operation. But a few years before they start the process of the, several years before they start the process of extending the life of the plant, and they were granted 20 more years of operation. So Angra 1 is going to go until 2044 as of right now. And they establish a long-term operation program. So that's why I put LTO on the side of Angra 1. And Angra 2 is still under a first operation license. Electronuclear, which is the operator, is considering extending the life of Angra 2 as well, but it's not there yet because it still have several more years to go. A challenge that Brazil has of right now is Angra 3. Angra 3 is a plant that was part of the agreement that Brazil had in the 70s with Germany. The Angra 2 was a result of that. So Angra 3 was supposed to be a sister plant to Angra 2. Construction had stopped in the 80s. And then restarted around 2010. However, they had several issues with funding, with bids and so on. So the construction has been restarted and stopped several times. Right now is in that state that I showed you in the first slide. So it is a construction site, and construction at this moment is stopped. They had restarted a couple of years back, but they had an issue with the company that was performing the project. So this has been what we call in Brazil a big white elephant in the sector, because it's very difficult to discuss with the government for future plans while this one is not sorted out. And there are, even though there are sides of the government that are very pro continue and finishing the construction, there are others that are against. So the sector in Brazil is currently fighting a lot to show the benefits of keeping this plan alive and finishing Angra 3. And Angra 3 is a German design, but has been updated with all the what was updated in Angra 2. So like digitalization and other sort of things that were implemented in Angra 2, being a sister plant were updated to the design of Angra 3. So because one of the because a lot of the concerns in Brazil is outdated technology. So is one of the things that the sector tried to clarify, is even though this is a technology that was defined back when Angra 2 started construction in the 80s and so on, there was updates to that design and updates that were already implemented in Angra 2, updates that were regulation demanded. So finishing Angra 3 won't be finishing an outdated plant, will be a design that has been brought to the reality of today. In any case, this is still a big challenge in the country. And it's difficult, as I said, to talk about future nuclear power plants while this is unsolved. A lot of sides of the government in Brazil are very skeptical of talking about new plants if this one is not sorted out. So it's also the sector is also trying to separate this project with future new technology projects like SMRs. Brazil also is very blessed in the sense of raw material. So Brazil is in the top 10 uranium reserves in the world, with only 30% of the land prospected. So, which means that 2/3 of the country, we don't know how much uranium it has because the whole country was not analyzed. And with only these 30%, 33, if you 1/3 of the country analyzed, put Brazil in the top 10 of uranium reserves in the world, and also have a complete capability in the fuel cycle. So Brazil can mine and produce fuel and deliver fuel. So different than many other countries, Brazil has INB, which is the Indústrias Nucleares do Brasil, which is a company responsible for mining and for enrichment. And Brazil has the technology to do all of this. So there is a handful of countries in the world that have the resources and the capability and the technology. And the enrichment technology is a Brazilian technology that was developed by the Navy back many decades ago. So it is a country that has this competence to do, but unfortunately, due to several aspects and government decisions, it still has only 2 power reactors, nuclear reactors. I put here just some major organizations. We do have Eletronuclear, which is the operator. According to the Brazilian Constitution, the government is responsible for operating the power plants. INB is responsible, as I said, for mining and so on, which is also a company tied to the government. CIMEN or CINEM is both the research and the regulation. So they are separating these institutions to have a separate regulation organization and a research and development organization. Right now, they are still together, but they are, even though they are in the same umbrella organization, they have different directories that operates the regulation and the research and development to make sure that they don't have conflict of interest. However, has been in the past few years has been putting law the separation to make sure there is even less perception of conflict. And NUCLEP is a heavy equipment manufacturer that was created to manufacture like steam generators, reactor vessels, and for the nuclear sector. They divert to also producing these sort of equipments, but for other industries. And right now they are also working on the submarine, so constructing submarines. because of course, if we are not building new reactors, the company need to make sure they had work to do. But they were able to provide, have equipments for other countries like Argentina. So they are still capable of doing so. So if Brazil starts to building new reactors, we do have in the country have equipment manufacturer to support the construction of new reactors.
Right. Thank you, Alice. Should we pause here? So I thank you very much for already mentioning some of the challenges and advantage of Brazil. But can we discuss in challenges and the limitations later? So we have other sections. Should we pause here and we continue the challenges later? Should we hand over to Princey? And do you have any experience to give us a brief introduction to the situation in South Africa?
Hello, hi everyone. Thank you so much. I only have one slide to share. Please, if
yes,
it's allowed.
you can make it very brief so we have more time in the following discussion.
Okay. I need to look for it. Okay. All right. Thank you so much. Good afternoon, good morning, good day, everyone. My name is Prince Simtombeni from South Africa. I'm the founder of Africa for Nuclear. One thing that I wanted to show everyone first before I speak is the true size of Africa, because what I've noticed is that whenever I travel around the world and people hear that I'm from South Africa, they would be like, do you know so and so from Kenya? And then I would realize that many people don't understand how big Africa is. So Africa is like, we have 55 states, 55 countries, and it has a land area of 30.37 million square kilometer, and which is enough to fit in the US, China, India, Japan, Mexico, and many European nations combined. South Africa alone is as large as the whole of Western Europe. We have over 62 million population. And the distance from Pretoria, where I'm currently at, to Cape Town, where the nuclear power station is at, is the same as the distance from London to Rome. And why I'm telling you this is that when we say African solutions for African problems, we mean exactly this, because oftentimes you find that when we do this benchmarking, energy benchmarking with other countries, they don't realize that our problems or our challenges are not really the same. If I just make another example, is that the coal power stations are based in Mpumalanga. Mpumalanga is just about over 100 kilometers away from Pretoria. And if you have to take electricity from Mpumalanga to Cape Town, which is a distance of about what? From Rome to Rome to London, that is a huge distance, but that is exactly what is happening, which is why we advocate for more nuclear power stations, so that at least we ease the burden on coal power plants that we have. Now, coming back to after the issue of Africa, just to give you an indication also of what challenges do we face in terms of energy generation, is that Africa is home to 17% of the world population, but it accounts just for just 4% of the global power, which is the lowest in the world. In estimation, there are over 600 million people who live without access to electricity, and like over 900 million people who live without access to clean cooking alone. And when we speak about per capita energy consumption in sub-Saharan Africa, with the exclusion of South Africa, it is just a disappointing 180 kilowatt hour per year, compared to around 13,000 kilowatt hour per year in the US and 6,500 in the EU, and a global average of around 3,500 per annum. So this tells you that this is a continent in crisis. When we put it simply, Africa energy generation needs to increase at least 20-fold to meet the world average consumption. So that is just another indication. But when we talk about the nuclear on the African continent, we have only one nuclear power station, which is based in Cape Town, as I have already mentioned, Koeberg Nuclear Power Station in South Africa. That's the only one currently. Koeberg in South Africa has 2 units. And in total capacity, it's 5% of our total electricity generation. South Africa's most electricity comes from coal. We have many coal plants and coal mines in South Africa. And the coal plants that we have currently, many of them are old and they are approaching their decommissioning stage. So what will happen when these coal power plants get decommissioned? Obviously, we need them to be replaced with another dispatchable power. And that option the option that we currently have in South Africa is nuclear in terms of baseload power replacement for coal. And that's one of the things I advocate for, the coal to nuclear, so that we repurpose these coal power plants with nuclear. We have tried one coal power station to repurpose it with renewables, wind, solar, and battery energy storage to be in particular. And the challenges that were faced there is something that South Africa does not want to repeat. And so that when we look at South African policy in terms of the policy direction, the integrated resource plan in South Africa, which we are following, it was Integrated Resource Plan 2019. It had nuclear capacity of 2,500 megawatt. So since then, the government has been trying to procure nuclear. Obviously, there are a lot of legislations and other regulations that they need to follow, and that's where the struggle is currently at. And we are hoping that because the minister has announced a panel of people that is going to assist him in terms of making sure that all the correct steps are followed in terms of the procurement of this 2.5 megawatt of nuclear capacity. But also, we have the draft integrated resource plan, which is due to be published. And that draft integrated resource plan, it has the capacity of around 14,500 megawatt of electricity, which needs to be there before 2050. So what I always say to people is that even though South Africa did not sign the pledge to triple nuclear energy, that was signed at COP28 in Dubai a couple of years ago, but if you look at the direction that they are taking, they are looking into tripling the nuclear energy capacity. But what we hear, South Africa speaks a lot about small modular reactors, which is fine by me, but I also do not think that, do not think that they should exclude the conventional nuclear power plants, because if you take into consideration that there's over 21,000 megawatts of coal plants that of coal that needs to be decommissioned, so they will need replacement as soon as possible. So I am for energy mix. I am for all technologies in nuclear technologies for South Africa and for Africa at large. But what we also need to keep in mind is that for a very long time, Africa has been made to be sort of, I call it a guinea pig of technologies that have not been proven somewhere else. So I want technologies that have been proven somewhere else to work, to be deployed in Africa, including SMRs. Let's see SMRs working in Europe, working in the US, so that at least we are able to speak facts when it comes to these energy technologies. So also in Africa, as I already mentioned, there's only one commercial nuclear power plant on the African continent, which is in South Africa. And currently, the Egyptians are building their nuclear power plant, El Daba nuclear power plant, which is going to be bigger than our Quebec, because theirs, the capacity is 4.8 gigawatt. The Russians are building in Egypt. And that plant is going to provide at least over 30% of their total electricity. We're talking about clean energy here. So Egypt is actually on the way to decarbonize their electricity, which is a good thing. And I really wish that many countries follow Egypt's steps, because it all starts with making a decision. You know, people always ask me, where are we going to get skills in Africa and stuff? But how are you going to get skills when you are not making a decision? You know, policy direction is very important. Once you publicize a policy to say we are going nuclear, you will see as many young people taking up nuclear careers, studying, because they would know that after their studies, at least they would have a high percentage of getting an employment now, which is not happening right now, because our young people, they go and study in China, in Russia, in France, and everywhere in the world. And at the end of the day, when they come back home, there are no nuclear projects for them to work on. And they now have to go around the world and start looking for employment. While I'm saying, I'm talking about our young people going somewhere else, we have many young Africans sitting in a diaspora working for other nuclear energy projects in other continents and countries except in Africa. And those people would want to come back home as soon as the decision is taken to say we are building. If I talk about South Africa alone, we have like in the UAE, the new nuclear plant that was built there. We have over 150 South Africans working in that project. So when it comes to skills, South Africa does have skills, and I believe that Africa also have skills. And now, when we look at other countries such as Kenya, Ghana, Rwanda, and Uganda, they have also announced their plans to build nuclear power plants. Kenya has even chosen a site where they're going to build it. But there were also challenges of anti-nuclear groups there saying they don't want a nuclear power plant there. And so they have to go and look for another site, which is, for me, I don't know, it's really annoying, because why would you be dictated to by NGOs in your country as a government? Because wherever they go, they're still going to encounter problems. So it means they did not do their public campaigns or nuclear awareness enough for them to get into, or for them to get the buy-in of the people, which is also important in this industry. You cannot build a nuclear power plant without being transparent and going on the ground and speak to people to make them understand why they need this nuclear. And yeah, so it's something that the industry has to improve on. But I'm very optimistic that these countries are going to finally build nuclear power plants, because I don't see these technologies being implemented anywhere else in the world. The biggest market is Africa, and which is why even those technology vendors from other countries, they need to look at how they can make sure that Africans understand what nuclear is and what nuclear is going to bring for them, and what opportunities are they going to get out of nuclear, because it's important for the implementation of these technologies and for the economic as well. Having said that, thank you so much. I think that's all I wanted to say in my introduction.
Yeah, thank you, Princey, for sharing the advantages and disadvantages in Africa. We do have a lot of electricity needs there, but the challenge would be how do we replace the current core power plants, and we need the policy to attracting more workers in Africa to build that power plants. So now I would like to open the next section, which is a bit of more about challenges and enablers in different regions. We already talked about policy, and there are also other factors about supply chain, the technology transfer. Also, we have Alice mentioned Brazil have a lot of uranium reservoir there, and they have the fuel cycle technology. So I would like to hand over back to Joan. How do you think, what are the biggest 2 or 3 enablers or limitations in different region or in the region you covered?
Right. Well, I think one of the most important factors is making nuclear power fit the requirements of individual countries. And one of the problems we have, for instance, in South Africa, is the instability of the grid. That there's a lot of disruption of the grid, largely, I think, because there's an imbalance between the distribution of different types of generation on the grid. Similarly, in some countries, the grid is not able to accept a large reactor. So we're going to be faced with Russia going in and selling 1,400 megawatt reactors in blocks of 4. And countries, for instance, if they're talking to Uganda, would we be able to imagine that Uganda would be able to accept large blocks of reactors, whereas Turkey is clearly able to do that because it's a country with local high population densities with an adequate grid. So I think that there's one of the factors is matching the reactors to the application, and SMRs are likely to be much more useful in some countries for their first reactors than larger reactors that are being supplied at the moment by South Korea or Russia.
Thank you, Jen. Thank you, Jen. Alice, you also covering the region of Spain. Can you give us some more information about how does the policy, supply chain, or SMR suitability in that space, please?
Yeah, definitely. So Spain is going on the different direction of many European countries. Right now, Spain is considering phasing out its reactors. So Spain has 7 operational reactors as of right now, which accounts for almost 20% of energy mix in the country. But the appetite for of this government is not to extend the life, even though the reactors could have their life extended to continue operations. And I'm not going to go over these, I'm just going to talk about the challenges. But there are 7 reactors in the country, and one of them has its operation until 2027, for example, which is Almaraz. And all the others have dates of finishing their operation license until 2035. And the current government is considering phasing out the reactors in the sense that they don't want to extend the life of any of those. So there is a big campaign to save Almaraz, which is the first one to have their life, like the operation license ending. The three power plants that are in the Catalonia region, which you may know, Catalonia region, which has like Tarragona, Barcelona, and so on, they have a better chance to continue operational, which is Vandellós and Asco. Vandellós 1 plant and Asco 2. But with the 7 reactors in Spain, the other 4 still need saving, let's say. So currently, the biggest challenge in Spain for the sector is overturning this decision and maintaining the reactors operating. So new reactors is not a discussion right now in Spain, because the focus has been to keeping what we have here operating. And there is, of course, a lot of studies and investments in fusion in Spain. They have a fusion reactor in one of their labs. It's, of course, not viable, but they use it for research, plasma research. They are part of ITER project as well. But it's years and years and years away from making it viable. But Spain has a big research project and so on, focus on that. But as I said, the biggest challenge here, I already mentioned the challenge in Brazil. The biggest challenge in Spain is maintaining the plants that we have open and producing energy, because it's 20% of the country. It's big amount of energy they produce. And we don't believe that renewables will be capable to replace it all as it's being advertised.
Right. Thank you, Alice. So we have already talked about the situation in different places, and we have noted the advantages or restrictions in different areas. So in the following section, I would like to put all those factors into a global landscape again. How does the globalization might help to solve the limitations in different regions? For example, how can we transfer the resources of uranium mines from Brazil to somewhere else? How does we transfer the fuel cycles? And Prince, you have mentioned you have lots of needs in Africa, and but you need the policy to attract more talent, and you also need the economy situation got to be better to help the development of nuclear. So I would like to hand this question to all 3 speakers. How do you think the globalization can help the technology transfer or nuclear development in different space, or what would be an ideal situation in your opinion, in all perspective? You can pick up any angles you want. Can we start with Jen again?
Okay, well, I think this is quite a difficult question because on one hand you've got countries like China and South Korea and Russia wanting to sell reactors, and then you have the issue of whether it's suitable for the countries that they're aiming at, and one of the problems is that because of the huge investment costs, Russia, using money that it obtained from gas sales, is building the reactors essentially for very low cost. But then Russia retains ownership of the reactors and will charge what they like for the electricity once they're built. So the countries could find themselves in a situation where they're being held to ransom by another country building reactors and then charging an enormous amount for them. I'd like to just mention one point for Spain, and that is that we had a dreadful situation earlier this year when the grid went down. Yeah. Now, Spain has been very edgy about admitting what the reason for that was. But people who know about the grid tell me that it's almost certainly because the amount of dispatchable power had decreased below 30%. And as we remove fossil fuel power, coal and oil and gas, which are dispatchable, that means the reactors can run in phase and keep the frequency on the grid stable. Once in Spain, that level dropped below 30%, mainly because of wind and solar. The grid became unstable. So having a baseline of nuclear power as part of the power supply could be extremely valuable as a low carbon way of keeping the grid stable.
Alice, do you have any comments on that?
Yeah, definitely. So I was here when that happened, and I was working, and then suddenly no electricity anymore. The cell phone signal was still working for a while, like an hour after, and then not even that. So we didn't have, not only we didn't have power, we didn't have any way to communicate with others on like how your friends and family are. A lot of people were stuck in elevators, in trains, and even like cable carts. And so it was a very scary situation where 15 gigawatts of energy just disappeared in seconds. So it is definitely what you were mentioning, one, and there is mixed messages on the media and government. And when we were advocating saying, see, we need nuclear because of that to bring more stability, the government say, oh no, nuclear caused actually issues because we needed energy to close the plants and so on. So this whole situation, it's still not very clear. Like the root cause analysis, it has not been fully, let's say, advertised yet of the situation. But for me, I agree with you. It just proves that we need more reliable power, energy security. On the globalization aspect that you mentioned, I would say that we need more collaboration in the sense of, if you look at regions like mine in Latin America, and you look at the technology vendors, as Professor Juan was mentioned, the price are not only steep because of the price of the construction and technology, but also exchange rates, inflation, supply chain challenges. Because if you look in Brazil, if you have not constructed a nuclear power plant in the past 30 years, we don't have an industry that maintained qualification for certain aspects of that. So has an additional cost of requalifying the supply chain to be able to do that. So it's very important to, even though we do have vendors and they are there to sell the technology and so on, but it's very important to have an international collaboration and to develop local supply chains and local resources as well to decrease the price of this for countries that need this technology for development. And if you look at the region of Latin America, even though we do have a lot of opportunities for SMR, we also still have a lot of opportunities for large reactors, because the amount of energy that is needed for development is very big. So SMRs, microreactors can come to support decentralized energy production, support decarbonization of other industries, but these regions still need large reactors to not only fulfill the demand as of right now, but to be able to increase the development of the region, to be able to bring people out of energy poverty. And so it's for me, it's a combination of collaboration, and it should be done by the countries that own technology, by financial institutions to help support the development of these regions in a way that is viable for them, while we're still being profitable for the organizations that are selling technology, and also have a focus on local development and local supply chain qualification to allow those countries to not only decrease the cost of the project, but also have the capability of producing, of continue the construction of not only one, but future fleet of reactors, being large or small. So it's a challenge. It's not an easy question to answer, but for me, it summarizes in collaboration.
Right, I see. Thank you very much, Alice. It does sounds like we do facing a lot of challenges in globalization, not just collaboration in nuclear. We do have difficulties in collaborating almost everything. So it does need a very stabilized society. We does need stabilized policy, and we need to see a good trending in the future. So in Princess, in your perspective, what would be a very ideal way of collaboration between the countries in Africa and countries in Africa with other countries?
Thank you. Before I answer your question, I just want again to just give a clarity on something. South Africa is one of the top producers and exporters of medical isotopes, in particular molybdenum-99. And if you go to other African countries, there's lack of nuclear medicine facilities. They don't have. And those that have, they have maybe a small number of them. They still have to procure the same from Europe or from Australia or anywhere else in the world. And why I'm telling you this, I'm telling you because I want you to see how big the problem is. And that's because we don't have flights that move directly from South Africa to another African country. So they have to via Europe or Middle East in order, if you are going to Ghana, you have to via Middle East to get to Ghana, Egypt. You see, that's the situation in Africa. It's even bigger than energy itself. And having said that, people always speak about just energy transition. And that concept we have also adopted as African countries. I don't mind South Africa adopting it because they have at least a number of people, almost 100% electrified. But if you speak about countries like DRC, Uganda, and other countries, why should you speak about transitioning when you have nothing to transition from? So number one is to adopt the correct language so that you can have the correct implementation strategies. They have no business in discussing transition when they do not have electricity altogether or energy altogether. So it's the right policies for right implementation. Now, having said that, I'm going to be blunt and say Africa does no longer need backdoor colonization in a form of energy technologies. So when people come to Africa, they need to start negotiating on equal footing because we are watching these things. It's not like Africans don't see things. We do see these things and we know who is here to actually help us industrialize or to negotiate with us, not from a position of of us needing them, but on equal footing, as I say. So that's all that we need. Come here, let's sit down and negotiate as partners, not as someone who's higher or above us. So we are ready for any technology as long as it's going to serve our economic needs. Thank you.
Thank you. Thank you for announcing the importance of energy equity. So now I would like to close the panel discussion, and we'll hand over to our audience for any questions.
Hello, can you hear me? Okay, hi. My name is Izzat. Just to bounce off what Juan said just now regarding like the financing and also the infrastructure. I would just like to ask Princey with regards to Africa, in terms of Africa, the entire continent addressing the 19 infrastructure issues, like provided by the IEA. What's the progress of the African continent?
I'm going to need some help because I'm quite deaf.
Oh, do you need me to speak louder? Okay.
Could you come down and speak directly to me, maybe?
I think the question is probably about the financing. I think the issue is probably about the financing condition in Africa and how does the IAEA progress in Africa continent. Is that correction?
Well, I'm not so sure I can answer that. I think that's
yeah. We'll hand over to Princey.
Shokai, I think he's referring to IAEA milestones approach. Is that what did I hear correct, Alice?
Yes, correct.
Okay, so South Africa, actually, we are covered in terms of the milestone approach because we already have nuclear programs. But when you look at countries like Ghana, they are very far advanced in terms of the IAEA milestone approach because they are at the procurement stage. They have done the groundwork of regulators, putting together regulators, the NEPIO and all these things. But yeah, they are now towards the end of procurement. And I think Kenya is also at the same stage, as well as Rwanda. I am not sure about Uganda, but for them having chosen a site, it means they are also advanced. Yeah, but I can assure you that in Africa, there's nothing that will happen outside the IAEA milestone approach. They are going to be followed, and that's the law of nuclear. You can't run away from it. So yeah, that's exactly what's going to happen. Earlier on, I mentioned equal footing. So now I'm talking about something else. Now, Africa has uranium. Now, when I talk about equal footing, is that with us having uranium, South Africa, Namibia has 10% of the world's uranium. Now, when you come to Africa and say, or to Namibia, South Africa, Tanzania, saying that you are going to build nuclear plants, but now you want to give us your uranium. If Russians want to come to bring uranium from Russia to Africa, where else we have uranium, how then can we collaborate to make sure that the uranium underground in African countries benefits people? How can we put together the enrichment plant, fabrication plant, so that we do not go outside to fetch these things? Yeah, so I think that's what I forgot to say earlier on.
Thank you.
So we have time for one more question in the room, if we have any. Three, two, one. Yeah. So with that, I think we should give a round of applause to our speakers. Thank you, Alice and Kunia, for joining the panel, and John in the room. Should we give a round of applause to them?